In number 1, they ask you to find r prime of 5.4. 5.4 is in this region, so basically I'm going to estimate that by using the average rate of change. In other words, r of 7 minus r of 5 over 7 minus 5. That ends up being 10 minus 6 over 2, 4 over 2. The answer is positive 2. That's the average rate of change, and that's approximately equal to the instantaneous rate of change of a nearby data point. In number 2, they are asking us to integrate the data. They basically want to find the distance traveled, and so the distance traveled will be the integration of the velocity. So basically what we're trying to do is approximate the integral of r of t from 0 to 15. They want to use right-edged rectangles, so that means that I'm only going to use these y values. Notice that the spacing between each x-coordinate is not the same, so therefore you cannot use any shortcuts. You have to find the rectangles one by one. In any event, the first rectangle has a width of 2 and a height of 8, so that's going to be 2 times 8. And then the next rectangle has a width of 3 and a height of 6. The next rectangle has a width of 2 and a height of the right edge of 10. And the very last rectangle has a width of 8 and a height of 20. And so you get 16 plus 18 plus 20 plus 160, 180 plus 34, which is 214 is the answer there. The next problem asks us to estimate the position at time 7. So to find the position at time 7, that's going to be the position at time 0 plus the net change from 0 to 7 of the derivative. And the net change can be found by integrating r of t. So they ask you to do this using trapezoids. So this integration right here has to be done by trapezoids. Notice that I only want to do it up until 7. So the first trapezoid, you average the two heights, and that would be 10 times the width, which is 2. The next one, you average the two heights, which is 7, times that width, which is 3. And the last one, you average the two bases, or the two heights, and you get 8 times the width, which is 2. So that's 20 plus 21 plus 16, which is 57. 57 is the approximation of that integral, and then you're going to add to it the position at time 0, which was 9. And so the answer, if you do this all out, would be 66 feet. In this next problem, they're asking us, why do we know that r of t has to equal 11 at some point between 0 and 2? Well, we notice that the r value is 12 initially, and then it ends up being 8 eventually. Because r is a differentiable function, that basically implies that it must be continuous. And if it's continuous, it has what they know as the immediate value theorem. It has to hit all the y values between 12 and 8. Well, 11 is such a value between 12 and 8, so the answer to this is the intermediate value theorem. We know that the function is differentiable, therefore it's continuous, therefore it must hit all the y values going from 12 all the way up to 8. In number 5, we know that r is equal to the rate of change of position. So r prime has to be the change in that rate, otherwise known as acceleration. In this problem, they're saying, why do we know that we're trying to figure out exactly what the acceleration has to be? Well, we know that this function is differentiable, and therefore it's also continuous, so it has the mean value theorem. And the mean value theorem says that the instantaneous acceleration has to equal the average acceleration at least once in this time window. So what's the average acceleration? Well, it's basically looking at this and this, which is r of 15 minus r of 0 over 15 minus 0. That's the average rate of change of the rate, and that's going to be 20 minus 12 over 15 minus 0, 8/15. That's the average rate of change of the rate. That has to equal the instantaneous rate of change of the rate, which we call acceleration, at least once. The answer is 8/15. In this last problem, they're asking you to find the integral of r prime of t as t goes from 2 to 7. This is the fundamental theorem of calculus. The integral of r prime is going to equal simply r itself from 7 to 2. This is going to be basically r of 7 minus r of 2. R of 7 is equal to 10, and r of 2 is equal to 8. So the answer ends up being positive 2. Ta-da!